Solar system. The solar system includes the sun and all objects that orbit the sun due to its gravity. These are some rather pretty images, completely not to scale, of various objects that do orbit the sun, that do belong to the solar system, including the sun, planets, comets, and asteroids. We believe that the solar system formed from a nebula. We've discussed this before. We call this the nebula hypothesis. This is how all stars are believed to be formed. You have a big ball of a cloud of gas and dust in space that starts to come together under the force of gravity until fusion occurs in the center and the star is born. The remaining debris collects to form protoplanets and finally fully developed planets like we have in our solar system. One of the parts of the solar system, the most obvious, is the planets. There are 3 requirements to be a planet. It has to orbit the sun directly. It has to have a sufficient mass to assume a round shape. If an object reaches a certain size, it melts and thus forms the most compact shape, which happens to be a sphere. So it has to be large enough to do that. This crosses out asteroids. Most asteroids are not large enough to reach this shape. And finally, it has to have cleared the neighborhood, meaning there's nothing else that it competes with in its orbit. It's merged together with all of the other formerly competing objects within its orbit. This is what eliminates Pluto. There are 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You are expected to memorize the order of the planets in order from the sun. The distance from the sun is what determines the characteristics of a planet. For instance, in general, the density of the material making up the planet decreases with distance from the sun. In other words, the more dense planets, the rocky ones, are close to the sun, and the least dense planets, the gassy ones, are far from the sun. Another part of the solar system is the dwarf planets. These orbit the sun. They're large enough they've got a round shape, but they have not cleared the neighborhood. Examples of these are Pluto, which had previously been considered a planet, but also Ceres, Eris, Makemake, and Haumea. All of these would have been classified as a planet under the old system, but now we put them together into one group that is more concise. They are the dwarf planets. They aren't big enough to have completely cleared out their neighborhood. The next group are called moons. These are any body that orbits a planet or asteroid that orbits the sun. So in other words, instead of directly orbiting the sun, it orbits something that orbits the sun. These are also called satellites. Asteroids are another group. This is possibly the most numerous group. These are solid rocky or metallic bodies that orbit the sun but don't fit the other characteristics. Most are in a belt between Mars and Jupiter, otherwise called the asteroid belt. Comets are one of the neater ones that orbit the sun. These are balls of ice and rock, or metal, and we also often call them dirty snowballs, rocky, icy creatures that we think may have large part helped us form our oceans. This is an image of a comet. It looks to be moving very fast, and it is, but from the point of view of Earth, it actually doesn't seem to be moving at all. It often looks frozen in just this shape. The photographer did not have to be lucky to capture this image. It would be very clear, and you could watch it sit there in the sky for weeks. The tail, which is the defining characteristic of a comet, is actually formed because as it nears the sun, the ice and other gases that form the body of the comet start to be vaporized by the solar wind. And this starts to steam and boil off the comet. And it produces this tail that shines in the sun's light. This tail will always point away from the sun. Doesn't matter in which direction the comet is moving. Even in this point in the orbit, when it's moving this way, the tail will point away from the sun. Halley's Comet is a famous example. It last appeared in 1986. It will next appear in 2061. It has a period, meaning an orbit, roughly 76 years long. Other parts of the solar system that sound very similar are meteoroid, meteor, meteorite. Meteoroid is the small solid fragment that orbits the sun. Meteor is the streak of light that it produces when it enters our atmosphere and begins burning up. And meteorite is the fragment that actually continues to land on Earth's surface. Meteors are often called shooting stars. They are extremely fast-moving, and we tend to have meteor showers. Whenever we pass through the remains of a comet, there's a great deal of debris, so we get lots of little streaks of light as these meteors burn up in our atmosphere. One that didn't burn up in our atmosphere started out as a 150-foot piece of asteroid, and it went hurtling through our sky long time ago, back when Arizona was completely uninhabited, and it left this crater 1.2 kilometers in diameter, 180 meters deep, extremely deep and wide. Another impact crater is this lunar impact crater. The planets. The terrestrial planet, terrestrial meaning land, are the 4 planets that are very close to the sun that are mostly solid. They are very much like Earth. They are Mercury, Venus, Earth, and Mars. They're small in diameter, high in density, rocky, few or no moons, no rings, and they do have impact craters. And these are images of them: Mercury, Venus, Mars, and Earth. Mercury is a ball of rock with an iron core. Temperatures range on the daylight side facing the sun, 800 degrees Fahrenheit, hot enough to melt lead. And on the night side, negative 279, cold enough to freeze air if we could transfer any air to Mercury. Mercury, because of this constant shifting back and forth from extremely hot to extremely cold, it has no atmosphere, no water. Any gases have long since been evaporated out, but it does have many impact craters, as you can see from this image. Venus is a runaway greenhouse effect, named for the god of love. She is the hottest thing in the solar system, saving the sun, and she is extremely poisonous as well. She has thick clouds, acidic rain, poisonous atmosphere. She's the only other planet in the solar system with active volcanoes, and temperatures go up to 890 degrees Fahrenheit. So she is hotter than Mercury, even though she is significantly further away from the sun. This is due to what we call a runaway greenhouse effect. There's so much carbon dioxide in her atmosphere that it traps heat inside the atmosphere, producing extremely high temperatures. Earth, we know well, it is the only planet that contains water in both solid, liquid, and gas. It's the only one we are aware of with life, and it's the only one that has an oxygen atmosphere. Finally, in the terrestrial planets, we have Mars. Mars is much smaller than the Earth, but has some really unique characteristics. It used to have volcanoes, but is since solidified, so it has no more volcanoes. And it has this incredible canyon along the side of it. It's called Valles Marineris. It is almost 2,500 miles long, 4 miles deep, and 125 miles wide. If we put it in the United States, it would stretch from coast to coast, west coast to east coast. Much deeper, wider, broader, and longer than the Grand Canyon, but formed much the same way, possibly by running water, and definitely from tectonics as well. The Jovian planets are the ones that are further from the sun. They're very gassy planets, and they are called Jovian because they are related to Jupiter. They're all Jupiter-like. Jupiter, Saturn, Uranus, and Neptune, very large. They're also called gas giants. Low densities, low density gas. But since they are so large, they have many moons, they have rings. They may also have a small solid core, but since they are gas, they don't have impact craters themselves. Jupiter is the largest planet in our solar system. It has a huge great red spot. That's what it's famous for. This is an image of it. This spot here is a hurricane that's been lasting at least 300 years. So as long as we've been looking at Jupiter through telescopes, we have seen this great red spot. And it's large enough that we could fit the Earth inside it. We also have Uranus. Uranus has been tilted almost completely on its side. It orbits this way, tilted over. So this means that during certain times of year, like for instance 1986, this part of the sun, no matter how it spun, was always pointing towards the sun. So this side, during its summer, the sun never set. And on this side, the sun never rose. Over here, the sun never sets. Here, the sun never rises. Only in what we would call spring and autumn does it have day and night. Moons of our solar system, most are around the gas giants. Earth has a moon. Mercury and Venus do not. Mars has 2 moons, Phobos and Deimos. Jupiter has 63 known moons. Saturn has 31. Uranus 27. There are various objects in the Kuiper Belt that have moons. Pluto has a moon known as Charon. There are many, many moons in our solar system. Some definitions for movement. Rotation is the spinning of an object on an imaginary axis. Rotation determines the length of a day. For instance, Earth has a rotation of 24 hours, roughly. Revolution is the movement around the sun. This determines the length of the year. Earth's revolutionary period is roughly 365 days. An ellipse is the name for the oval shape of a planet's orbit. Kepler first figured this out. An ellipse, unlike a circle, which has one center to it, an ellipse has 2 fixed points that define the center, and they are called foci. This is showing how an ellipse is put together. You have 2 foci. One is the sun. The other one, we're dealing with planetary orbits, is actually an imaginary point in space. But the ellipse orbits both of them. This is how we draw an ellipse, typically. The planetary orbit is being drawn by the pencil, and the sun is one of the foci. All planets have a slightly elliptical orbit, not perfect circles. Eccentricity is the measure of how far off the ellipse is from being a circle. For instance, Earth is not a very eccentric orbit. It's a fairly normal orbit, so to speak. It's almost a perfect circle. If you were to look at it, you would certainly consider it a circle. Pluto, on the other hand, is a relatively eccentric orbiting dwarf planet. It has a very oval-like orbit. What determines eccentricity, if you were to look at the formula, is the distance between the 2 foci divided by the length of the major axis. So the distance from focus to focus divided by the width of the entire ellipse along the longest point. As the 2 foci become farther apart, an ellipse becomes more oval, and the eccentricity approaches the number 1. As the foci are brought closer together, the ellipse becomes more circular, and the eccentricity approaches 0. Earth's eccentricity is closer to 0 because it is very, very circular. This is what a high eccentricity would look like, and this is a low eccentricity orbit. This is closer to what the Earth's orbit would be. The elliptical shape of an orbit causes the planet to vary in distance from the Sun. For instance, the Earth is at the closest point to the Sun, called perihelion, in January, and we're furthest from the Sun in July. That's called aphelion. I usually think A for away, furthest away. Inertia says that an object at rest stays at rest and an object in motion stays in motion, unless acted upon some opposing force. Gravity is the attractive force between any two objects. The greater the mass, the greater attraction, and the closer the objects are, the greater the attraction. This means that in an orbit, which is a balancing act between inertia and gravity, when a planet gets closer to the Sun, it is under the pull of greater force of gravity and so moves faster. So the Earth, being somewhat closer to the Sun, not as much as in this picture, you couldn't see how much closer it is in an image. Perihelion, we move fastest in January. Aphelion, we move slower in July because we're further away. See, faster here, slows down. Faster here, slows down. Now, this change in distance is not what's determining our seasons. Because notice we are closest in January, which is not when we in the Northern Hemisphere are hottest. That is not our summertime. So please do not get that confused. Distance from the Sun has nothing to do with our seasons. The distance from the Sun is only affecting the speed of our orbit, which doesn't truly affect us at all. But we do need to be aware that a body moves faster near the Sun and slower away from the Sun.